don't you just hate the internet sometimes? So I needed to time some C++ code, and I wasn't in Hazel, or I wasn't in like some common library where I already had like timer classes set up and everything like that. So I was like, you know, C++ timer, like let's just Google C++ timer. Maybe, you know, I'll just get some quick code to copy paste. And then I clicked on the first result, which is from c++.com. And that's the entire premise for this video. We're gonna discuss timing and how to like time something, and specifically how to set a 5-minute timer, which is what this person is trying to do. We're going to discuss how to achieve that in C++. We're going to go through why this forum thread is just comedy, and we're also going to talk about like, is this actually hard? Like, because like a 5-minute timer in C++, like that doesn't sound like a very difficult thing to do, but is it? Hey, I'm working on a project where I need to set a 5-minute timer. Once timer is up, I need to do something. I'm not sure how to do this. Any help will be greatly appreciated. All the way back in 2013, which to be fair is not actually that long ago. I'm also confused as to why this says it's 8th of June, 2022. And I'm assuming that's part of the reason why it was the first result, because it's kind of recent, whereas the last thing is actually also in 2013, but whatever. And then closed account says, include windows.h. It's funny how like literally the first line of code is already wrong. You don't want to involve any operating system specific APIs because that obviously limits it to that operating system. Like this is now no longer portable. You can't run this on Linux or Mac or whatever other system you're running on because you're not using the C++ standard library, which is portable. It is implemented on all of the major operating systems, and therefore all of the code within that will run on all of those operating systems. Then we do a little using namespace std, which you know, is fine. I mean, it's definitely not as big of a problem as include windows.h, but also using namespace std. I made a whole video about why I don't like doing that ages ago. Maybe it needs a bit of a revisit, but I'll have it linked up there for you guys to check out if you're interested. Fair warning, the first 2 minutes is me making coffee. It was a different time back then. Okay, and then we have the main function. Wait 5 seconds, timer 5, and then fireworks. And then the timer function just calls sleep, which is from the Windows API, hence why we include windows.h. And we just sleep 4 seconds times 1000 because I guess sleep takes in milliseconds. Okay, so dissecting this a little bit. The main strategy here, the main way that we basically wait 5 seconds is by literally waiting 5 seconds, meaning we release the kind of resources bound to that thread and we just say do nothing for 5 seconds. I'm not gonna lie, that's not the first thing I thought of when I thought about I need to set a 5-minute timer. I am a game engine developer. That's kind of my main thing. And so because of that, like I always picture applications or just C++ programs running like in a loop, basically. So in a game engine or a game, you have this thing called a game loop. It's just the application loop. I mean, pretty much all applications have this, to be honest, not just games and game engines. But because we have like a persistently running loop, that allows us to do things every frame. And every frame is also something that, you know, can be defined in a variety of different ways. But fundamentally, like in a game engine, usually every frame is basically every time the application updates, which in a real-time running application will usually be at the refresh rate of your monitor. So it's fairly frequent. Could be 60 times a second, could be 144 times a second. It's pretty quick. Now, of course, in a game engine, you might have several different threads and they might be kind of running, they might have their own frame intervals and things can get more complicated. But fundamentally, you still have like basically a place within your application where you can constantly and frequently run some code. And so because of that, my first instinct was kind of just like, okay, well, what about a timer? Like, what if we just wrote like a literal timer using like the Cherno library in C++ to actually like check what the current time is now, and then next frame we can check it again. And then when that accumulates to like 5 minutes, or we could do a countdown from like 5 minutes, there's lots of ways to do that, but we would actually use like the timing functionality of our platform here to see like, is 5 minutes over? Basically like this. I've set up a little example here. So here's our simulated application loop. This is what you would have inside like the application or game engine or whatever running every frame. And then we basically have a start time, which is just the current time. And then every frame, as long as we're running our timer, we're gonna get the new current time, which of course is gonna change every frame. I'm just simulating a little 5 millisecond sleep here so that it doesn't run, you know, 100% CPU usage. And then all we have to do is basically see the difference between now and start time, which remember we set outside of the loop, and see if it's greater than or equal to 5 minutes. I'm using chrono literals here so that I can actually write like 5 min instead of doing std chrono minutes with 5 inside. And then that's it. That's our timer. So obviously once we exceed the 5 minutes, it's complete and we can do whatever we need to do and stop checking the timer. That was my first thought, because I guess I just write code within a context that has this kind of application application loop that's constantly running. But of course, that's not always the case, which is why like I'm not necessarily knocking this whole sleep thing. I'm just commenting on why like that wasn't really my first go-to thought of just let's sleep for 5 seconds. Speaking of sleeping, one thing that you definitely should not sleep on is learning. Are you learning? Are you constantly getting better at things? Because if you're looking for a way to get into computer science, learn some math in a way that's more doing rather than just simply watching, then Brilliant.org, the sponsor of this video, is perfect for you, and they have a 30-day free trial that you can use to try out their entire platform for free. Brilliant.org is an amazing website filled with lots and lots of really high-quality courses on various STEM topics. If you're just starting your programming journey, then one of the most challenging things at the beginning is kind of rewiring your brain to think like a programmer. And Brilliant's engaging and interactive beginner computer science courses really help you with that by presenting things in a really fun and interactive way. And once you get those basics nailed down, you can progress into their Python courses where you'll write some actual real Python applications. And then there's math. Who doesn't love math? Math is so important for programming. I always talk about that, and Brilliant's math courses are like my favorite on the internet. The reason why is because this visual, engaging way of learning is just perfect for math. From the everyday math course, which is perfect for beginners, to more advanced topics like calculus, Brilliant has these widgets you can play with that help you interact with the math and visually see what's going on and how the numbers are working. But then they'll also quiz you to make sure that you're actually paying attention, you're learning all of this content, you're not just consuming it like some zombie, which can happen if you're just watching videos. And as I mentioned, Brilliant have a 30-day free trial, so you don't have to take my word for it. You can just check out their entire platform by going to brilliant.org/Cherno. The link will be in the description below. And if you do go on to like it, then that link below will get you 20% off an annual premium subscription. Huge thank you to Brilliant.org as always for sponsoring this video. And now back to sleeping. So yeah, I think sleeping is probably the best way to go if you don't have that loop. If you just want something to execute after, say, 5 seconds or 5 minutes, as the OP wanted, then I think sleeping is an acceptable solution. But the problem with this particular code is that this program, of course, literally does nothing for 5 seconds. And I guess if you adapted this to 5 minutes, then this program would just print, wait 5 minutes, literally just hang for 5 minutes, and then do the next thing, which, to be fair, is kind of what the OP asked for. I mean, they said once timer is up, I need to do something. They didn't mention anything about having to do something while the timer is running until their second post here. Thanks for the reply, but is there a way to set a timer and processing continues? To my understanding, when you use sleep, all processing stops. Is there a way to use set timer in a non-dialogue program? Like, I don't know, like a non-kind of modal dialogue blocking program? I'm not sure what that means. Any advice will be greatly appreciated. You can just make one timer that sleeps every second and a I equals 300, because 300 seconds is 5 minutes, and I minus every second. When I is 0, then do what you want to do, that face. This is where I began to lose it. Okay, thanks. Can you give me an example of what you are describing, just to make I am following? Thanks. A double thanks for that. And here we go. Here's the code. This is it, guys. This is what we were waiting for. This non-formatted piece of garbage. Int I equals minutes times 60. Okay, well that part is correct. Sleep 1000. So we're sleeping for 1 second, just straight out of the gate inside this timer function. Then we do what you want in meantime. So I guess this is the processing continues part of it. And then we do I minus, which subtracts the seconds that we sleep for from like 300 to 299 now, because we've slept for a second. And then if I is greater than 0, meaning we still have more timer to execute, then we recursively call ourselves, otherwise like we're finished, so function that you want to use process. Anyway, I'm guessing that's the processing post timer. So after the timer finishes, that's the function we run. Okay, so let me get this straight. We sleep for 1 second, 300 times. We do what you want in meantime, which by the way, no consideration is given for how long this takes. Because if this takes like 10 milliseconds, then we're not gonna be done in 5 minutes, are we? Because this takes time to execute, I guess, but we don't care about that. That doesn't exist. But then it's the other like situation where we recursively call ourselves. So at the end of this, like we've created 300 stack frames. We've got a function 300 stack frames deep. And inside that stack frame is when we finally run the function that we want to do after the thing. So, I mean, I've just got no words for this. I don't know what to say about this. So then 300 stack frames deep is when we finally execute that function over here that we wanted to do after. But like, again, I think, I'm not sure what the biggest comma is. Is the fact that this is recursive instead of just like a normal for loop, maybe, which would have worked the same way, but minus the 300 stack frames. or the fact that there is zero consideration given to this processing that happens. So therefore, it's not actually going to be exactly 5 minutes, is it? And there's some discussion about what min, start valve, whatever. And then finally someone new points out that using Windows sleep function makes your program for Windows only, so it's better to use this one. And they actually suggest a completely different solution, which actually was like, I guess, more similar to my first thought, as I mentioned, because this uses actual timing. It actually calls time inside C time, and it just, I guess it takes in like a timer. What is this int timer exactly? They didn't really mention that at all. And then we just compare like the current time with the start time, kind of like I did. And then if it equals exactly the time in which that greater than equal to is much more safe, then we break. And of course, there's no like actual sleeping inside here. Like this is 100% CPU usage because it's going to be running this loop as fast as possible on that core. There's also no actual processing happening while the timer is running because this is the processing. But I guess they mentioned that maybe you should use multi-threading. So that's nice. I mean, minus points for suggesting the boost library in a place where C++11 already exists though. Yeah, not happy with that. And then finally, the very last post of this entire thread by someone who just has never posted before on this thread. This is a new person who just decided to chime in here with, let's be honest, the best solution so far. They actually start a thread which sleeps for 5 minutes and then prints hello world. And because they've done it that way, it means that after this thread starts, which is immediately here, they can actually run some code concurrently on the main thread and then just wait for the 5 minutes to be up basically before they terminate the program, before the program finishes. Now, this is, like, to be completely honest, a fairly good solution. I think that especially compared to like the rest of this thread, it's pretty good. To be honest, like the main issue that I have with this is, first of all, the kind of multi-threading implications, which we'll talk about in a minute, but also just the fact that it's just not a very pleasant thing to use. What I mean by that is the code that we can do while we're waiting for the timer happens here, and then the code after the timer finishes runs within the Lambda kind of function that actually is the timer. I would probably set this up a little bit differently just so that we have, like, for example, a clear callback that we can run when the timer has actually finished. That way we can basically reuse this functionality, because everyone else, like, you know, to their credit, I guess, did actually provide an external function that you can call, even though some of them were a little bit weird. This is just happening all within the main function, which I know this is just an example, but still, my version would just separate this out a little bit more just so that it's reusable, and so that, I don't know, I'm big on making sure that the underlying code that runs whatever you're running is separated from your kind of user-based code. So what I mean is, like, this is obviously something the user is doing, and this, like these comments, I mean, are something the user's doing. Everything else in this entire function really is just internal implementation details. And I'm a big fan of concealing that so that you're basically bringing the user code to the spotlight, especially because something like start a timer for 5 minutes, like a function called like start timer 5 minutes, that provides all of the context you need. You don't actually need to see the rest of the code to understand how it works. You can be like, okay, well, yeah, that's a 5-minute timer. And then maybe I want it to call like a callback or something when it's finished, because I need code to execute after that timer is done. Now, speaking of code executing after the timer is done, that's the other important thing that I think about here. The person originally said, once timer is up, I need to do something. But then they also want to set a timer and processing continues, which, you know, if we go back to my example, you don't need multi-threading with my example, because it's just inside a loop, it's on this thread, and since you're running this, well, at this point you're running like this, each iteration of this application loop every 5 milliseconds, but of course that could be variable, but either way, you could just do your stuff here, and then the timer complete code you can run here. So it's like, this isn't multi-threaded, but we're still able to do stuff while the timer is running, if that makes sense. And I've actually talked about this concept a lot when we were like rewriting the asset system and doing like the asynchronous asset system and the content browser panel, like thumbnails and stuff like that in Hazel recently, because I don't necessarily think that multi-threading should be like the first go-to as soon as you realize that, well, I want this happening and I want that happening, because you can see in this example, it's just on a single thread, but we still achieve something that almost feels like it's running in parallel. But the difference with this specific thing is that obviously if we actually run code here, we're running it on this thread. We're not running it on the main thread. And that makes me, like, I don't want to say a little nervous, because it's not exactly, it doesn't make me like nervous, but it does jump to the front of my mind here, is that okay? Is executing our code and our work that we need to do on a different thread to the calling thread where we started the timer, is that acceptable? Because it might not be. In a lot of cases, you might need to manipulate data that is owned by like the main thread, for example. And if you do that on the timer thread, then that could have certain negative implications that could lead to bugs and problems and race conditions. So therefore, if you did write your code this way, which again, sleeping on a thread for 5 minutes, like sleeping is not like the most accurate thing in the world. I think it's accurate to about 1 millisecond, meaning that like if you need something like microsecond level precision, you can't just sleep for 5 microseconds. But obviously in the context of 5 minutes here, there's not gonna be like a margin of error that's gonna be unacceptable for you, probably. But if you did go down this route, then you would have to consider that if you can't run this on this thread and it has to be executed on the main thread for whatever reason, then you probably have to like queue it up and basically dispatch it for like, future execution, like for example, next application loop on the actual main thread. So then if we take this basic example here, because as I mentioned, it is the best inside this thread, then this is probably how I would write it. There's a lot to unpack here, so let's take a look at it. First of all, I'm using futures and async here, which by the way was introduced in C++11, so it was technically present and available during this thread. And you don't technically have to use these, they just kind of wrap and make easier the functionality that you could just achieve with a thread manually. But it basically lets us just start, like from an API point of view, just start a timer for 5 minutes and then have this Lambda here, which will execute at the end of that timer. So we're basically saying that after 5 minutes, run this code. And the way that it does that, I've dressed this up with template parameters. And the only reason for that is because I want the duration here to be variable. So you could use minutes, you could use seconds, you could use milliseconds, whatever you need to use, you can use. And basically what it will do over here, as you can see, is with the example of milliseconds, it will actually use the std milli type instead of like minutes or whatever, which is what you see over here. So it's a ratio of 60 here. You can actually see the definition for all of these over here. So that's what that ratio was of 60 for minutes. Now we are packaging this up in a future and we're using std async with the async policy to actually dispatch this. So that just means that this Lambda inside here will be executed asynchronously. So we'll kind of spin up a thread for it. It'll sleep for our 5 minutes over here. And then we call a callback, which again, just moves the function that we want to execute, the work that we want to do afterwards, it just moves that into the calling code. So it just cleans it up a little bit and makes this more generic, as I mentioned. But then whilst this is being executed asynchronously, we still want to have some degree of control over it. As in, we want to make sure that we don't terminate the program before this is finished, but then we also might want to check the status of it. Hey, is that timer still running, by the way? What's going on with that? And so that's where this future comes in. It's just void, doesn't return anything, but it lets us basically keep tabs on this. It lets us check to see, for example, what the status is, like has it finished or not? And in this case, I'm just showing an example of terminating this entire program because it's in a while true loop. We're breaking from it when the future has finished. So when the timer has finished. But this periodic checking of it also allows us from the main thread to technically receive like updates and progress of the timer. So if we wanted to like display the actual timer in the UI or something, we could achieve that. We'd probably have to use promises for that as well if we wanted to do it correctly, because we can just set a value on a promise and then receive it on this thread. That would probably be the more correct way of doing things. And then meanwhile, over here in our main loop, we can keep processing and doing all of that work that the OP mentioned while we're waiting for this timer to actually finish. So quick summary, this is the work that runs after the timer has finished. And then this over here is the work that runs while the timer is still running, in this case on the main thread. And so if we set this to something a little bit more reasonable, like maybe 5 seconds, if I run this program, then we'll see we're processing. That's our main thread work. And then after 5 seconds, the timer has finished and therefore we've finished because we have that code there that breaks if that timer is complete. And then that's it. The application terminates and we're done. So yeah, that's how that goes. Funnily enough, this wasn't even the kind of timer I was looking for. I just wanted to time how long a function took to execute. Didn't need to actually set like a 5-minute timer, but oh boy, the internet. But it did lead me to also think about timers because they do sound really simple, but then when you think about it, it's like, well, do I want to actually run like a chrono timer and like actual timing code? Do I want to sleep for like 5 seconds or 5 minutes or whatever? If I do that, what thread do I sleep on? Do I block the main thread? Do I not block the main thread? Then if I want to execute code code afterwards, does that have to happen on the main thread? Can that happen on the calling thread? Speaking of which, by the way, if you did want this to execute on the main thread, then you basically have to like dispatch this to the main thread, meaning it would go into like some queue that you would then process here. You'd probably just use like a regular queue or a vector or something with like a mutex to lock it so that you can execute it every frame over here if there's anything inside that queue or vector, and then have this actual like callback function be queued for execution later inside the main thread. What are your thoughts on timers? Did this make sense? Did you agree with me? Did you disagree with me? Let me know in the comment section below. If you have a better solution, you can also suggest that. Also, let me know if you want to see more videos like this where I just explore the internet, and I'll see you guys next time. Goodbye.